Next, we have our Khan Academy assignment, dilate triangles. This time we do have a point of dilation that we're going from. So, and then we do have our green shape here that we get to move around to create our dilation. So you see here we have triangle ABC, and we're going to create triangle A prime, B prime, C prime. Our scale factor, get my marker here, our scale factor is 3. So that means each of our points need to be at 3 times the distance away from point P as the original points are. Let's start with point A. Notice how point A is a distance of 1, 2, 3, 4 away from P. So that means point A prime needs to be 3 times that much. So if we do 4, 1, 2, 3, 4 times 3, we get 12. So let's count 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Why my marker's not leaving a dot there for me? Anyway, did I get the right spot? I might have to count again. So I'm going to move this corner over here where I think it was, and just count one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. Okay, so now point C, this one's tricky because it's at a diagonal. So I'm going to do point C last, if I can. In fact, I might just move that out of the way just so that it's going to be going kind of in the right direction. We can see that it's going to actually be straight up and down from A. Oh, and look how long that distance is right there. From A to C is 3. So if we're multiplying by 3, that would be 9. And right now it says it's 7. So that's going to be done there at 9. I think I've got C by doing it a slightly different way. Instead of counting from point P, I just took the length of AC and multiplied by 3. Okay, so now from point B is 3 away from point P, right? So that means that point B prime is going to be 3 times 3, or 9 away from point P. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that point should go right there. So I've taken all of these sides, excuse me, and their distances from point P, and I've multiplied them by 3 to figure out the points for my new image. Check it, and I've got it. Okay, same idea here. Draw the image of ABC under a dilation whose center is P and scale factor is 1/2. So the center is P, so we need, and scale factor 1/2. So all of the points we need to look from point P to the points of our triangle. So I can see right here from point P to point B, it's like 2 diagonal lengths. So half of that, because our scale factor is 1/2, will be right there. And then point A from point P, that one's going to be a little trickier. Let's do that one in a second. So then we have this point over here, point C from point P, which is 1, 2, 3, 4 diagonal lengths. So half of that would be 2 of those, so right there, correct? So now we just have to figure out where this piece is going to go to make it fit correctly. And we could actually kind of draw a line between A and P, and that would help us figure it out a little better, because this point A prime has to be right on the line between P and A, and then the distance between A prime and A needs to be the same as the distance of A prime and P. If I just eyeball that, it looks pretty close, but let's look at the measurements here and see if we think we've nailed it or not. So this length AB is 10.2, and it looks like right here it's telling us that B prime A prime is 5.1. Well, that is half, so that's good. And then 8.5, and then it shows half of that is 4.2. That could just be a rounding error, because I feel like that's in the right place. And then this one, 8.9, and half of that, 4.5. That's a little bit off as well, but again, I hope it's just a rounding error. I'm going to check this and see how I did. Okay, good. So again, those numbers are a little bit off, being exactly 1/2, because they were rounded to make them actually work. Interesting. Let's go on. Okay, A prime, B prime, C prime is the image of triangle ABC under a dilation whose center is P and scale factor is 1/3. Which figure correctly shows A prime, B prime, C prime using the solid line? Okay, so we've got our original picture up here. And all of our answer choices, I'm guessing, will have that same blue picture in them, all of them labeled ABC. So if they're not all the same, then that would be dumb and would immediately tell us to eliminate a particular problem. Okay, the next thing we're doing is doing a third, but it has to be a third from point P, which means since point P is in the center of triangle ABC, then triangle A prime P, B prime C prime is also going to have P in the middle of it. So looking at all of our options, we do have answer B that has point P in the middle of our A prime, B prime, C prime, and we have answer D with P in the middle, but which one is actually a third scale factor? So I feel like B is a 1/3 scale factor, whereas D might be more of a 2/3 or maybe even 3/4 or something like that. It's not even half the length of the original triangle. So again, I chose B because point P is in the middle of triangle ABC. So for the dilation, point P has to be in the middle of our image, A prime, B prime, C prime, and it also needs to be a third the size. Let's check it. And we got it. Okay, next, draw the image whose center is P and scale factor is 4. So we've kind of done these already where we've got the distance of a corner from P. So like A is a distance of 1 from P. So if we want this to be A prime, we're going to go a distance of 3 from P. So that we're, oh, it's scale factor 4, my bad. So we're going to go a distance of 4 from P. So that the first pre-image is a distance of 1, scale factor is 4, so the image is going to be a distance of 4 from P. Then the other direction, look how B is a distance of 2 from P, so that's 8. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, and that's where that point's going to go right there. I'm going to count it again. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, and then C here is a distance of 2 from P, so that's going to be another 8, but it has to be right in line with C and P. So 1, 2, 3, 4, 5, 6, 7, 8. So that should put that point about there. Let's count again. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I think I got it the right place. Let's look at the numbers really fast. So we've got 3 times 4 is 12. Is 2.8 times 4 11.3, and is 2.2 times 4 8.9. Hopefully the shapes look the same shape but different sizes. I think I've got it. Let's check it. Awesome. Good job.